So multiplying and dividing. 2 is adding and subtracting. 3 is solving equations. So you have to know how to multiply, divide, add, subtract before you can solve the equations. And then 4 is just graphing, which I think is pretty easy. So there are 4 sections. So we will start today on Tuesday and get through 3 of those sections this week. Do the last section on Monday next week, and then take the test for Unit 7 before your Thanksgiving break. So the test will be due that Tuesday night of next week, because that will be the last day. So when you come in next week, we'll finish Section 4 and then go through there. So those are the 4 sections in Unit 7, so it'll be pretty quick. And then Unit 8 is exponents and logarithms, and then Unit 9 is statistics. So we have 2 to go after that. All right, so this is the first page. The essential question on here is, how do you simplify multiplication and division of rational expressions by factoring? So all of this is going to be back to making sure you know how to factor. So if you factor correctly, then you should be able to solve these, which will make today's lesson a whole lot easier. So in example 1, and then the you try, these are just the basic, these are factoring problems where we're canceling out things. So the only thing, x plus 1, you can't do anything to, x minus 5, x minus 5. This right here, x squared minus 1, is something that we can factor. So that's the difference of squares. Anytime you have 2 perfect squares, you can make one a positive and one a negative, and that's how you factor it. So this will turn into, it's still x plus 1 and x minus 5. And then on the bottom, it is still x minus 5. The x squared minus 1 will factor. It's called the difference of squares. So we have x plus 1 and x minus 1. That's x squared minus 1 factored. Now, when you get to this point in any of the problems, so everything is factored. Every piece of that fraction has been factored. Now you can cancel out things that are on the top and the bottom. So x plus 1 and x plus 1 goes away, and x minus 5 and x minus 5 goes away. So there is nothing on top of the fraction. So if there's nothing there at the end, you have to put a 1 to hold its place. And on the bottom of the fraction is x minus 1. And that's the final answer for A. So all we did is factor the one thing that wasn't factored yet, and then we canceled out what we can cancel out. B asked me, has 2 trinomials. Trinomials are when we're going to figure out what 2 numbers multiply to give me this and add to give me this. So we're looking at the top. What 2 numbers multiply to give me a negative 12 and add to give me a positive 1? 4 and so a positive 4 and a negative 3. So 4 and negative 3, if you add those together, you get positive 1. And 4 times negative 3 gives you negative 12. Okay, so that works. Now, B, on the bottom, what 2 numbers multiply to give you 12 and add to give you 7?
Positive 4.
Yeah, so they're both positive on this one. Okay, so now you factored both. So that's the key, is just factoring them. Then you're able to cancel out. So we can cancel out the x plus 4s, and we're left with x minus 3 over x plus 3. Can't do anything there. That's your final answer. So it's basically factoring right now. It's what we're learning, or what we're going over again, kind of reteaching, is to make sure we can factor. X squared plus 6x plus 9. You need 2 numbers that multiply to give you 9 and add to give you 6. Yep. So they're both positives. So you add them both, they give you 6. And you multiply them, they give you 9. And then the bottom is a difference of squares. So we just have to know the square root of 9, and we know that's 3. So it's going to be a plus and a minus. So the square root of x squared is x, and the square root of 9 is 3, so that's called a difference of squares. That's where we write the plus and minus. So we have an x plus 3 on the bottom, and we have an x plus 3 on top. We can cancel out 1 for 1, but we can't cancel out both of them. So we're left with just x plus 3 over x minus 3, almost like the last one. Just a little bit different. We go to B. B is the first one where your factoring is a little bit different. In B at the top, you're wanting to take out a GCF. So you always have to look for, is there a greatest common factor I can take out first? So the GCF of 4x squared and 8x is what? 4x. Yep. So if you take out 4x, you've got an x left here, and 8x divided by 4x is 2. So if you take out a 4x, you're left with x plus 2. On the bottom, you're saying two numbers that multiply to give me 8 and add to give me 6.
2 times 4.
Mm-hmm. So it's x plus 4 and x plus 2. So now you are able to cancel out the x plus 2's. And your answer is 4x over x plus 4. And that is the final answer there for the you try part B. So we've done 4 of these right now. All we did in those 4 was simplify the fraction. And the way we simplified the fraction was by factoring. So we factored a trinomial. We factored what's called a difference of squares, where we do the plus and minus. We factored in that last one using the GCF. These are all factoring methods that were learned in Math 1, okay, and then redone in Math 2, and then done again in Math 3. So this is the another time we're seeing it. At this point, we want to multiply. Multiplying means it doesn't make it any harder. You can think of it as just one big fraction. We're just going to be doing 4. We're going to have to make sure all 4 parts are factored. The top left, the bottom left, the top right, the bottom right. So if we look at example 2, we're going to say what two numbers multiply to give me negative 8 and add to give me a positive 2.
Positive 4 and 2.
Positive 4 and negative 2. Okay. Then down here, we're looking for two numbers that multiply to give me 3 and add to give me 4.
1 on 3.
Yep, 3 and 1. Okay. On the other one down here, x minus 2 is just x minus 2. There's nothing you can do there. And then that last one, 3x plus 3. What can you do to 3x plus 3? Yeah, greatest common factor. So they both have a 3, so you can take a 3 out and then write what's left. That would be x plus 1. It's very important to be able to do that. Okay? So you have factored the top left, the bottom left. You took out the GCF in the top right, and then the bottom right was already set. So now you are able to just cancel out like terms like we did earlier. So x minus 2's will go away, and the x plus 1's will go away, and we'll write what's left. What's left is 3 over 3 times x plus 4 over x plus 3. That's your final answer in example number 2.
Question.
Mm-hmm.
Could you have just used the box method and multiply and then simplify? I mean, not simplify. No.
No. No, we have to factor.
I mean, yeah, factor it, not GCF.
Yep. All right, example 3, simplify completely. So you look at the top left, x squared minus 9, that's a difference of squares. Again, you got to know when you have a difference of squares, it means you're subtracting, and these are perfect squares. So that's x plus 3 and x minus 3. Square root of 9 is 3. On the bottom, you're looking for two numbers that multiply to give you 6 and add to give you 5. That's a 3 and a 2. So x plus 3 and x plus 2. On the top up here, you already have an x plus 2. And then in the bottom right, you have 3x minus 9. So you can again take out the 3, right? And you're left with x minus 3. So your GCF on that one. So you had three different things. You had a difference of squares, you had factoring a trinomial, and you had a GCF on there for factoring. So that's good. Gives you a good idea of all the stuff. So the x plus 2's go away, the x minus 3's go away, and the x plus 3's go away. So you have nothing on top of the fraction, so you have to put a 1, and you have a 3 on the bottom. So the answer is 1/3. Okay, so we're going to do the same thing with question, with part A and part B. So I'm going to give you a chance to try to factor those and then cancel them out. So I'm going to let you try that and then we'll go back. All right, so in A, on the top left, you're saying what multiplies to give you 84 and adds to give you 19. That would be 7 and 12. So we're going to do t plus 7 and t plus 12. On the top right, you have 2t minus 2, so you can take a 2 out of both of those, and you're left with t minus 1. In the bottom left, you have your GCF of 4. You can take a 4 out of both of those, and you're left with t minus 1 also. Then in the bottom right, two numbers that multiply to give you 14 and add to give you 9 are 7 and 2. So t plus 7 and t plus 2. So now we can cancel out what they have in common. So the t plus 7s will cancel out. The t minus 1s will cancel out. Okay. Now, one thing that you see here, you have 2 over 4 that are outside of the parentheses. And so since you have the 2 over 4 outside of the parentheses, that would reduce to 1/2, right? So 2 over 4 would reduce to 1 over 2. It would reduce to 1/2, sorry. So that 1, though, is not really necessary because you already have the t plus 12 up there. So up top, you have t plus 12. You really have a 1, but you don't need to write that. On the bottom, you now have a 2, and you have t plus 2. So a lot of people, when they do a problem like A, they leave it with 2 over 4. If you leave it with 2 over 4, it's wrong because you didn't reduce it. So you can't leave the fraction as 2 over 4. When they're outside of the parentheses, you can reduce those fractions. So that's your final answer there for A.
I don't understand.
In B, you're going to cancel out the x plus 3's.
Mr. Weaver?
1 second. You're going to cancel out the x plus 3's on the top and the bottom. So x squared plus x minus 6 is two numbers that add to give you a positive 1 and multiply to give you negative 6. So that's a positive 3 and a negative 2. That's where I got x plus 3 and x minus 2. X squared minus 25 is the difference of squares. So that's where I get x minus 5 and x plus 5. The x minus 5 on the bottom is just there. X squared plus 4x plus 3 is x plus 3 and x plus 1. So 3 and 1 add to give you 4 and multiply to give you 3. So now I can cancel out the x plus 3's. I can cancel out the x minus 5's. And that's all I'm going to be able to cancel out. So my final answer is x minus 2 and x plus 5 over x plus 1. And that will be my final answer for part B. Except the only difference in multiplying and dividing is that you flip the second fraction at the very beginning. So if it says one fraction divided by the other fraction, what it's really saying is you do a plus 2 over a plus 3 times, and now it looks just like what we just did, a squared minus 9 over a squared plus a minus 12. So division is just flipping multiplication. And that's what it always is. So if you divide a number by 1/2, you're really multiplying a number by 2. If you divide a number by 2, you're really multiplying a number by 1/2. So division and multiplication are the inverse. You just flip it, and now we have multiplication, and now it looks like exactly what we've been doing. So it's nothing new there. So when they say multiply and divide rationals, if you can multiply them, you can also divide them, because you just flip it, and now we're back to multiplication. So now we got a factor. On the left side, there's nothing to factor. So the a plus 2 is there. The a plus 3 is there. A squared minus 9 is the difference of squares. So square root of that. So you have a plus 3 and a minus 3. And then a squared plus a minus 12. So we got two numbers that multiply to give you negative 12 and add to give you a positive 1. And that is what?
A plus 4, A minus 3.
Yep, a plus 4 and a minus 3. Okay, so if we look, the a plus 3s will go away, and the a minus 3s will go away. So we're left with a plus 2 over a plus 4. And that is your final answer. So all we did was flip that fraction. Now in example 2, why does it look different? Well, here's the case in example 2. So in example 2, this, I'm going to try to explain what it looks like. B squared, it's just written differently. B squared over 25a squared minus b squared divided by, that's what it's saying, b over 5a minus b. That's what that problem is saying right there. It's saying that fraction divided by the other fraction. Well, we just said, if it looks like that, divided by, then we just change it to multiplying, right? So b squared over 25a squared minus b squared times 5a minus b over c. So all we did now was change it to multiplication. So it was division, and now we flipped the fraction and changed it to multiplication. The problem started with this divided by this, and we flipped it, and now it's that times that. So b squared, there's nothing you can do. 5a minus b, there's nothing you can do. So up top, we just have b squared, and we have 5a minus b. Nothing we can do there. The b on the bottom, there's really nothing we can do there either. That one is a little bit trickier though. The 25a squared minus b squared is a difference because you're subtracting of squares. They're both squares. So remember, in a difference of squares, you're always doing plus and minus. So what is the square root of 25a squared? 5a. And what is the square root of b squared? Which is b. So it's 5a plus b and 5a minus b, which helps us cancel these out. Okay? Now, there's one more thing you can do. You have b squared up top. That means there's a b times another b, and you have one b on the bottom, right? So b squared is basically b times b, and then this is just 1b. So you can cancel out 1b on both of them. So instead of b squared, now you're just left with b on top. And on the bottom, you have 5a plus b. So you're able to cancel out a b on top and a b on the bottom. It's the same thing. Some people have trouble seeing that. B squared is the same thing as saying b times b, and then b on the bottom. So you're able to cancel out a b on the top and a b on the bottom. So you're left with just b on top. That's simplified completely. Whew. Okay, so b over 5a plus b is the final answer. So now we get to the last two. So we're going to scroll down, and then, so you're going to take a, and you're going to write it as a division problem, and then you're going to flip the second fraction to change it to multiplication. You're going to factor. So in A, you have the GCF in two of them that you need to do. One of them is a difference of squares, and one is just regular factoring of a trinomial. And then in B, all you have to do is flip the fraction. You have two GCFs to work with and one difference of squares. And all you have to do is cancel them out. So the goal today is the factoring. If you're not able to factor by Unit 7 in Math 3, then you would be in trouble for this unit. But that's why we've practiced it all throughout, so that hopefully by now this will be the step you can do. So this is multiplying and dividing. So we'll give you a chance to do these two division ones. On the first one, I wrote down negative 12b plus 18 divided by b squared minus 25. That's the first fraction. Divided by 4b minus 6 over b squared minus 3b minus 10. So I rewrote it, and I changed it from division to multiplication by flipping that second fraction. So the b squared minus 3b minus 10 is on top, and the 4b minus 6 is on the bottom. Now, negative 12b plus 18. Negative 12 and 18, I can take out a negative 6. And if I take out negative 6, negative 12b divided by negative 6 should be 2b, right?
Yeah.
Okay. That should be 2b. And then, that one should also be 2b. Good. So that should be 2b. And 18 divided by negative 6 should be negative 3. B squared minus 3b minus 10, two numbers that multiply to give me negative 10 and add to give me negative 3. That would be a negative 5 and a positive 2. If you add those, they give you negative 3. If you multiply them, they give you negative 10. So I've got that. B squared minus 25 is a difference of squares. So square root of 25 is 5. So I got b minus 5b plus 5. 4b minus 6, 4 and 6, I can take out a 2, and I'm left with 4b divided by 2 gives me 2b, and negative 6 divided by 2 gives me negative 3. So I factored everything. Now, see what I can cancel out. So I have a b minus 5 and a b minus 5. I have a 2b minus 3 and a 2b minus 3. The only other thing is on the outside of the parentheses, I have a negative 6 over 2. So what's negative 6 divided by 2? It's negative 3. So it should be negative 3, and then b plus 2 over b plus 5. And that's my final answer. So again, I simplified what's outside of the parentheses. So that negative 6 over 2 is simplified to negative 3 over 1, or just negative 3. Okay, in B, I had 3x plus 12 over 2x plus 4 divided by x squared minus 16 over x plus 2. So I flipped the second fraction to make it multiplication. 3x plus 12, the GCF is 3, so I take out a 3, and I'm left with x plus 4, because 3x divided by 3 gives me x, and 12 divided by 3 gives me 4. The x plus 2 on top just stays there. 2x plus 4, I can take out a 2, and 2x divided by 2 is x, and 4 divided by 2 is 2. And then x squared minus 16 is the difference of squares. So the square root of 16 is 4, so I can do an x minus 4 and an x plus 4. So now the x plus 4s will cancel out, and the x plus 2s will cancel out. 3 over 2 I can't simplify, so I have to leave that, okay? So it's 3 over 2, and then x minus 4. And that would be my final answer for the division problem. Okay, so really all I'm doing in these problems is factoring and simplifying. That's all I'm doing. Factoring and simplifying. If it's a division problem, it's really a multiplication problem that I just need to flip. Okay, so if it's division, it's really multiplication. I just got to flip it, and now it's multiplication. That's really it as you go through that. 2 pages of notes that go in there are just examples. There's an example of multiplying rational expressions, and there's a page that talks about dividing rational expressions, okay? And all it does is show you basically what we were doing, how you change it from division to multiplication, and then how you factor it, okay? Now, don't make a couple of these. I'm going to go over 2 of these real quick. Don't make them harder than they are, okay? So I'm going to go over number 1, and number 10, because I think people try to make these 2 harder than they really are. So number 1, you're supposed to multiply straight across if you can. So that's 2a squared, and then b times b is b squared over b squared, and then there's a c and an a, okay? So, very simply, the b squares will cancel out. You have a squared up top, which means a times a, so you have 2 a's up there, and you only have 1 a on the bottom, so an a will go away, and so you'll be left with 2a over c. So that will be all that's left in problem number 1. So again, you want to go straight across. 2a squared, and then b times b is b squared, over b squared ca. So the b squares will cancel out, and then you have a squared over a. That means you have a times a up top and just a on the bottom. So one of the a's will cancel out. You're left with just 1a up top. The number 2 is still up there, and you're left with just a c on the bottom. Okay. If you look at 2, 3, 4, 5, 6, all those are factoring. You need to be careful whether it's dividing or multiplying, right? Because if it's dividing, you got to flip the fraction. Okay, let's move down to number 10. And I think number 10 is an easier one. It's just that people mistake it sometimes. Now, take a note of this. So, you have all these numbers, right? The 24 and the 8. Look at 20. You don't have to necessarily look at, you can look at what numbers go with what. Look at 24 and 8. What is 24 divided by 8? 3, right? So 24 over 8 we can reduce to 3 over 1. So do that, right? 15 over 25 we could reduce to what? 3 over 5. Yep, that's fine. Okay, now that makes that multiplying a whole lot easier. Okay, 3 times 3 is 9, and 5 times 1 is 5. So there's my numbers. All right, now notice I have 3 x's, so I have x to the third up top, and I have x squared on the bottom. These are like exponent rules, if you remember that. You're supposed to subtract your exponents. But if you have 3 x's up top and 2 x's on the bottom, you're going to be able to cancel out 2 x's on the top and the bottom, so you're going to be left with what? X, just up here. Yep. And what about the y's? You have 5 on the bottom and 2 on top.
3 on the bottom.
3 on the bottom. Yep. Y to the third. So you'll be able to cancel out 2 of them on the top and the bottom, which leaves you with y to the third on the bottom. So that's your answer there in number 10. So there are times where you are actually able to simplify. Now, the other way you could have done that, it wouldn't be wrong. You could have actually said 24 times 15. And 24 times 15 is 360. And then you could have said 25 times 8. And 25 times 8 is 200. And you could put in your calculator 360 over 200 and simplified it. And that's 9 over 5. So it's okay to do it that way too. I was just showing you how it will reduce just by looking at it. So most of them look like what we were working on today. But these, the 2 I just showed you, number 1 and number 10, they count those as easier than what we were doing because you don't even have to factor. We didn't even have to factor in those. So like number 1, number 10, and then on the second page of this, number 18 and number 20, they count. They think those should be even easier than what we did. So 1, 10, 18, and 20. Those are the ones you don't have to factor at all, right? Because you're just simplifying them like we did right here. The other ones, we need to try to factor. We need to say, and factoring, there's 3 things that are going to happen in here, and that's it. There's only 3 ways that you're going to have to factor. Number 1 is taking out the GCF. That's like in question number 3 when I have 2x minus 10. You got to take out a 2 and you got x minus 5 in parentheses. You may have to factor a trinomial like number 6. You may have to say what 2 numbers multiply to give me -8 and add to give me -2. And then thirdly, you may have to have a difference of squares. And a difference of squares, I don't even see one on here. That's a difference of squares. So really it's just the GCF and factoring a trinomial is the only 2 things you would have to do to get through this. Remember, they have mixed up multiplying and dividing. So be careful to know whether you're multiplying or dividing to see whether you need to flip the second fraction or not. And that will be the only big concern there. Okay? So if you have any questions, I'll answer it as you go through.